Hello everybody and welcome back. So today for this afternoon, we have this lovely little photo of myself down in the corner because I accidentally ripped the cable that connects my camera to my computer. So we are out of one of them. Whoops. Anyway, welcome back to day 2, part 2 of the CAD Code and Circuits workshop. We're going to pick up with where we left off with the 2 homework assignments that I gave you all before the break. And so we're going to solve these 2 problems in Tinkercad, and then we are going to move over to building a circuit board and how to design circuit boards. So, without further ado, let's break out this problem. Let's grab it and let's go to Tinkercad. Awesome. So, let's drag our Arduino in to start. So we can get a little place to do some typing. We're going to switch to text in Tinkercad and continue. We'll post that in there. Hit enter a few times so we can read it. Alright, so problem 1. Connect a push button so that pressing it turns the LED on and off. Alright, so first step, well, I guess let's clear out this code that we don't need. And let's head over to Google. Arduino push button. Cool. So got a lovely little article here. The push button is a component that connects 2 points in a circuit when you press it. The example turns on an LED when you press a button. Hey, this is actually what we want to do. And this is why I love Arduino. I just looked over at the camera and the camera's not there. So, whoops. Anyway. We connect 3 wires to the Arduino board, yada yada yada. Let's get down to the example. So this looks like what we want to control. Alright, it looks like we have a little tutorial here. So, let us pull in a push button, and then we will learn some more about it. And like we introduced the breadboard last time, we're going to do all this good stuff on a breadboard. And we are going to pull in push button. Perfect. Okay. Remember how we talked about keeping different terminals and parts of circuits separate? Each of these exists on its own row. Alright, so what do we got? Oh, we'll also want an LED. Oh man, why does that keep popping up? Let's move this over real quick and let's zoom out a little bit. Okay, so we'll want an LED. Whoop. Drop that on our breadboard. We will want a come on. A resistor. Drop that there, and then we'll want some wires to connect this to the breadboard. Cool. So we know this LED wiring up from our previous example, so if you need help with that, have to go back and review the video from the previous lesson, which will be on YouTube later today. Alright, so the LED pin is actually 13, so let's move this to pin 13. Perfect. The in pin is on 7. Alright, so we can copy all this code. Actually, let's see. I feel like we're missing some bits. Oh, here we go. Connected to a digital pin 13 when pressing a push button attached to pin 7. It illustrates the concepts of active low, which consists in connecting buttons using a 1K to 10K pull-up resistor. Okay, so all the bits that I skipped over up here, I sometimes jump around articles like this. So it says we connect 3 wires to the Arduino board. The first goes from one leg of the push button through a pull-up resistor. Okay, so let's grab a wire, spring it over. Actually, we can just, what did it say? It said The first, we connect 3 wires to the Arduino board. The first goes from one leg of the push button through a pull-up resistor, which is 2.2 kilo ohms. Let's add a resistor. Is there any way to rotate these? Rotate. Perfect. Whoop. Okay. So now we should be able to drop that there, and then it says that that resist. Oh, we have to set the value. Can we change the value? Doesn't look like it. All right, we need another resistor. What did it say? It said 2.2 kilo ohms. Perfect. Now we will rotate it. Drag it right here. All right, and then it said I think the other side of that goes to the 5-volt power supply. Okay, so we'll run a wire here to 5 volts, and then we'll connect our actual 5 volts around to this rail here. Cool. The second goes from the corresponding leg of the push button to the ground. Alright, so we're going to open this image and zoom in on it. Okay, so it looks like this resistor here is connected to 5 volts, and this line goes here. This is very hard to read. Let's go peek at another circuit. Maybe this one. Okay, this is a bit easier to see. Okay, so one side goes to 5 volts. This is different. One goes through a resistor to ground. Okay, so let's delete this wire. Let's try this again. Oh no, we did want that wire. It's this wire that we wanted. Let's delete these. Let's start again. Let's leave the resistor in there. Let's move this wire out of the way. Perfect. Okay. So one side goes from here to the resistor and also to pin 2. And the other side of the resistor goes from here, and then that goes to ground. Okay. And then the opposite, diagonally opposite side goes to 5 volts. Perfect. Okay. So, I wonder if there's code actually attached to this, because that'd be helpful. Cool. Let's copy this code. Alright, so our button is on pin 2. Our LED is on pin 3. So we're going to need to move those about. Our button is on pin 2. Our LED is on pin 3. Just moving the wires around so it's a little bit more obvious. And it says, alright, this should work. We've gone through all the pin modes before of inputs and outputs. Cool. Let's see what we get. So if all's run well, we can press this button and nothing happens. Interesting. Okay. So let's see. What do we got? The LED is on pin 3. Goes to resistor, goes to ground. And that ground goes to ground. And then 5 volts to our push button. Let's maybe change this to opposite and see if, what did this tell us? So it looks like the LED is not connected correctly. Interesting. What is happening? This resistance is too high. That might actually be it. This is supposed to be 220, which we learned in the last bit. So if we reset, oh right, we can't change it. If we do this, nope, nothing's happening. All right, so let's add some serial printing, which we had reviewed in the previous lesson. And let us print out the button state. So we open our serial monitor, we see that it's low. Okay, so it looks like our button's turning on. So it would lead me to believe that somehow digital write the LED high if the button state is high, else we write it low. So we can see the state changing, which is interesting. Actually, really have no idea what's happening. LED is on 3, which it is. Is it because the LED is backwards? I don't think so. I wonder if this is an issue with the breadboard. Oh no, why doesn't the escape key not work? I can't delete this. Can I undo? I'm undoing code now. What is happening? Yikes. Okay. Oh, man. Hey, Latip, welcome back. Currently struggling with Tinkercad. I've gone and made a whole mess of things. Okay, let's start here again. Let's add our code in. We just undid on accident. Oh man, I've really... It's a bit weird to have not real wires and things. Let's see. Okay, if we press this down, it does turn on, but the LED is not turning on. Currently stuck. Can't figure out why the LED is not turning on. It is 220 ohms, which it's supposed to be. This should actually be on 3. I'm so confused. What if we just get rid of all this logic? Oh, that doesn't work. That doesn't work either. All right, just manually comment it out. What if we just do digital write pin 3 high? Sometimes I can't figure out whether it's the code or it's the circuit. And so I just want to like sanity check myself. And turning on 3 does not turn on the LED. Interesting. Let's just delete all of this. try again. Alright, so we're going to want a resistor of 220. Sometimes it's good to just tear everything up and try again. Why does this keep opening? Oh, because if you type anywhere out of this search box, that's annoying. Alright. Okay, so this needs to go to, oh no, this side needs to go to 3. This side needs to go to ground. Okay, I feel like something's weird with the breadboard is weirdly somehow not making connections. So this is me doing a little sanity check with myself. Just completely removing the breadboard from the equation. You sent the one you did. Where did you post it? Oh, check out Slack. Wait, did you post in general? I don't see it in chat. Yeah, I'm in chat. I'm in the general channel. Oh, weird. Okay, cool. Let's see what you did. No, I don't want to zoom in here. I want to open the image out. Open a new window. There we go. Okay. Oh my gosh, am I doing the LED backwards? I am. Oh man. Yikes. Alright, hopefully this works. The heck? Digital write pin 3. It's exactly what you have. Also, I like that this. What am I doing wrong? So we're going in the crooked side should be where the power is coming from, which is pin 3. Power coming in from pin 3 to the crooked side. Out the other side. Alright, I can't tell. I have not used. I'm about ready to be done with this software for the day. Is it? Okay, not really sure what's happening. So anyway, this is roughly how one would solve that problem. Cannot fix it, not really sure what's happening. Anyway, problem 2. Pick one of the components in Tinkercad or that you have in your kit, go to Google and learn about it, and then use it in a circuit. Alright. Just going to grab one of these components. Not going to go too far into it. Alright, so we'll just go learn about the LED RGB. So this is how I'd Google it. So we have a lovely little tutorial here which walks through how to use such a thing. So it says we'll need, similarly, 220 ohm resistors, a breadboard, jumper wires, Arduino, all the stuff we've seen before, and then a little example with an RGB LED. So RGB, red, green, blue, means we can get all colors of the rainbow: white, black. I guess not black because this is only light. But that's what we can do with this LED. Sorry, I guess I already knew that. Pretending like we're learning this for the first time. But okay, so I'd come through here and we'll notice kind of from our schematics, we see these triangles and lines again, and so we can see that this is a red light and a green light and a blue light, and the three of them together are contained within this little thing. And we'll notice that we can kind of see how it's wired up. So if we connect like the negative side to ground and then we run power through RG and B, or if we do the other way around, run 5 volts in the plus side and then we can run RGB out the other way. And this is how it might look if we were to wire it up. So 3 different pins in the Arduino, 3 different resistors to this, and then 1 wire to ground, and then we can write code to individually control each of the 3 colors. And then you get some sample code, which you can run through and test and try out as it looks like it. We set up our 3 pins, have them as outputs, and then we loop through changing the colors. Looks like there's some color highlighting issues here, but it looks like he flashes through red and then green and then blue and then all these other colors here as well. And then a lovely little video of it working as well. And yeah, so this is the joy of Arduino, is you get all these awesome tutorials and things, and you can learn each of the components in isolation and learn a whole lot about them, which is awesome. So that is it for the homework. Does anyone have any questions before we move on? All right, cool. So let's switch over to PCB design. So what is a circuit board? Sorry, a PCB. A PCB stands for printed circuit board, and the idea is that you take everything that you designed in Tinkercad or on your breadboards or things like that, and you kind of turn it into a little bit more of a permanent structure. And so we can see one such example here is this is a push button that you can actually attach to a little printed circuit board. And so you can see on the right how it's attached, and then you can put some pins in there and then use that in a project. This is one very simple PCB, and the idea is that you take all those wires that are kind of all about your circuit board and they become traces. You can see like these light red lines here, and that they will conduct electricity. And then you can attach your components by soldering these little holes, and then you have very secure connections that won't break apart, and then you can do various things with them. So an Arduino itself is actually a printed circuit board. A lot of the things you'll find in your computer, printed circuit boards as well. So we are going to open up EagleCAD, and we are going to learn a bit about EagleCAD. EagleCAD is software that is used to make circuit boards, and we will make ourselves a circuit board. And then I'll show you how to order one, and then we will call it a day. Cool. So this is EagleCAD. When you open it up, this is the view that you get. And you can come in here and we'll create, if you right click on projects, we can create a new project. And we'll call this CAD Code Circuits. We'll collapse this other one, and we will create a new schematic. So schematics are where we start If you recall, in the previous lesson, we talked about some basic schematics. Let's see if I can bring that tutorial back up. So these are the basic schematic bits that we talked about before. So we have resistors, and we have our 5 volts, and our ground, and our LEDs, and things like that. And then they combine together. I can't remember if this shows how they combine together. Yeah, so you can see how you can start to combine things together to make kind of layouts for circuit boards. And so this first step, these schematics, are kind of you just laying out everything on your breadboard and getting everything connected up. And then the second step is you turn it into a board. And the board is where you actually kind of physically position the parts relative to each other. So the schematic is more focused on the electricity, and the board is more focused on the beauty, the layout of the physical design. So if we wanted to real quick make a circuit board around making our blink LED sketch that we talked about before, if we wanted to turn that into a circuit board. So the first thing we would do is you come in here and we'd want to add parts. So we get this very kind of intimidating list of parts. But luckily we can search. And also we're going to jump to sparkfun.com real quick. And say you're looking for a part on SparkFun, and so you look for an LED and you go, oh yeah, I want to use these in my project. And so you look at these LEDs, and let's see if we can figure out like the info sheet. So these are not actually helpful. Is there any more documentation about these LEDs? Not quite. Okay, let's go back. Let's see if we can look at another one. How about these? All right, so it looks like it has, in this pack, we have various LEDs, and it looks like we have 3mm size, 5mm, and then 10mm. And just from experience, I know that 5mm, oh hey, it links back to that page. Okay, so 5mm is the standard size of LEDs, and we want to add a 5mm LED to our project. And these are Pth LEDs, and I believe that stands for so Pth stands for through hole. So there are two different kinds of components you can add. There are through hole and there are SMD, which are surface mount. I personally prefer through hole components. So through hole go through the actual circuit board and then you solder them on, whereas surface mount do not go through and they sit just on top. So a good example is actually here, different kinds of Arduinos where this chip here has kind of like legs on it or prongs, and they go into the Arduino, whereas this is just sits on top of the Arduino. So we want to start out with some 5mm LEDs. So we'll come back here and we'll search for 5mm LED. And the joy of having SparkFun actually integrated into EagleCAD is that we can come through and we can look at parts from SparkFun. So we can read kind of, this comes with experience, but I can see that this is an LED, it's a 5mm LED, PTH, so it's a through hole. And we can kind of tell when we see these green circles, it means that the wires will actually, this is just where the LED will go. We're basically just creating a place to put it now. And so we hit OK, and we can drop an LED in. And up next, if you recall, we'll also need a resistor. So we'll search for a resistor. I'm curious if we can search for PTH resistor. So not a potentiometer. We'll just go back and look for resistors. I'm wondering if okay, so we have spark on resistors, and we want to do 220. I wonder if we can search 220. Can't search 220. I don't quite understand the search functionality, to be honest, in here. Let's just search resistor. Let's go back down to SparkFun. Okay, so it looks like this actually has the footprint of what we want. You can see the symbol here that we recall from the previous bit. We can get little descriptions here of what this is. So it is a resistor, commonly used for quarter watt through-hole resistors, 0.3 inches between the holes. So that sounds good. So we'll drag that in. We can right-click to rotate. So we'll rotate our resistor and we'll place it there. We're just getting our components out in a space. So that's the first two bits. And then we need a way to actually connect it to the Arduino. So if we come back and we look at just the diagram, actually we can jump back in here. If we look at the Arduino, we can see that Arduino can take in what we call jumper wires, or wires to connect it to other circuits. And we can put them in these black spots here. And these black bits are called, oh gosh, why am I forgetting their name? Header pins, right? I believe they're called header pins. Yes, header pins. So we want female header pins, which look like this, and we can connect this to our circuit board that we designed so that we can then run a jumper wire from our circuit board to our Arduino. And so for what we're designing, we just need 2 header pins. So let's see if we can go down to SparkFun and look for connectors. And I believe 02 means that it's a row of 2, which just looks good. And sometimes, not always, but you'll get links to what the header pins look like. And I see female header pins here, and it actually links to a larger row, which you'd have to cut down. But you could cut this so that you just take 2 of those header pins and you could solder them onto your circuit board. So we'll select this, we'll place this here. And that's all we need. Any questions up to this point? Hellcat asks, how do you get the SparkFun library? It comes by default, or no, it doesn't come by default. Sorry about that. If you come down here to Open Library Manager, yes. So if you come to the Library Manager, you should be able to search, or sorry, you want to go over to Available. So we're using SparkFun, the available ones, this whole giant list. It looks like I can't click to scroll. There we go. So a lot of different things we can use here. And I believe, so searching for Adafruit, so that's actually in here. So I could click on the download button maybe, or click use. There you go. So you click use, and then, yeah, we now get access to those parts. I'm actually curious to go see what comes with the Adafruit package. Let's see, let's just peek at any component. Oh. Wonder where this link goes. Looks like a whole bunch of information about that. That's pretty cool. But yeah. Any other questions? Cool. So we have a little bit more time for chat, but I'm going to slowly start rolling towards the next step. Okay, so the next step is to add traces. And so traces are to circuit boards as jumper wires are to breadboards, and they're the way that the electricity actually gets around from part to part. So the two ways to do it is you can either click on net and you can click and drag about to create them. I'm going to hit escape to remove that, or you can actually click on the move command, click on components. Click on components is actually a little bit confusing. You're looking for this plus that's usually sometimes hard to find actually. But if you don't click on the plus, you can't move the component about. So if I click on the component, you'll see it change colors, and now I can move it about. And if I hover over, oh, I thought it would hover and do it. Okay, I guess it's not. But if I connect the points of the resistor to this bit here, and then pick it back up, you'll see that now they are connected. And if I didn't mean to do that, I can just click on the line. I thought you could click delete. Oh, right, sorry. You need to select the trash can, and then click on the line, and then you can delete it. And we'll go back over to our move tool. So let's position this here. Position. Okay, let's think about this. So if we go back over to our what we had drawn out, we go from the LED to the resistor to ground, and then 5 volts. So LED to resistor. So now those are connected, and we'll need to add some more wires. So we'll add from one side, this will go up. The other side, this will go up. And we can come over here and if we click on the rename tool, we can name these things. Actually, I can't remember which one changed the. Okay. So we'll name this, and we'll say this is to Arduino. And this is a connector that will go to the Arduino. And we can say this is our, I guess R1 is an acceptable name for a resistor. We want to give it a value. So 100K is not what we want. We want 220 ohms. So we'll change that down. And we'll give the value to this LED here. I want it to be blue. So I'll write blue. I'm going to fix my mistake. So that's blue, and that's to Arduino. And we'll next want to call out that this one line here is for ground, and this other one is a pin, because we'll connect that pin to somewhere else in the Arduino. So I believe we can name our traces. So I clicked the naming tool, clicked on this trace, and we'll just call this pin. And we'll bring that out over here, and then we'll name this other one, and we'll call this ground. And this is now a completed circuit. Any questions up to here? So we've now at this point fully defined all the bits that we need to turn this into a physical circuit board. So to switch over to the creating the board, we come up here to the menu, and there's a little button you can click that'll switch from schematic to board. So we'll click that. It looks like the board does not exist, so we'll create it from the schematic, and we want to go yes. So what we get is this new window where this black box is our entire circuit board. So it's very big, see relative to our components down here. So we'll want to resize this after we drag in our components and get them positioned nicely. So we'll come in here with our move tool. Again, we have to grab the center. So this time it's the yellow plus. And we'll drag this into the area of where the circuit board is. As you're holding them about, you can right click to rotate them. So if you want to position them more nicely, like you can see here that these are crisscrossing, and maybe to make that nicer, we can left click and do that to rotate. What these yellow lines represent is the traces for our connections of where the electricity will flow. Again, we can see this one looks like it's a little bit crisscrossed, so I could either move it about to uncrisscross it, or can rotate. So I'm going to make them look nice. one here. Cool. So everything is about where it should be on the circuit board. So now we can click and drag these lines down. Be careful as you're dragging, you can kind of end up rotating them in weird ways, so just try and make sure that they're totally vertical and totally horizontal. Cool. So now we'll zoom in, so we can use the middle scroll wheel to zoom in, and if we click down, we can drag it about. So these aren't actually traces yet, these yellow bits. They will be traces, but we just have to say where the traces will go. So similarly with the breadboard, how we choose where wires go, with traces we need to define where they go. So we do that by coming over here to route airwaves. And so we can either do this automatically or we can do this manually. So I'll first show you the manual way. Is we click route and we come over here and we click on a starting point and we can begin to lay wires down, or traces down, sorry. So there's a good starting point for that, and then we have to connect this other one, connect this last one, and we're done. And now electricity will flow if we print out this circuit board along these red wires. Maybe we didn't like that, so we can come over here to the rip up. We can click one and delete it, or you can shift click, sorry, not shift click, is it control click? If you control click, you can completely rip them up. And we'll show you, so maybe we want to position it some other way. If you want to go, I don't know, out to here and then down in. And if we didn't like that, we could click on it, sorry, on the route airwave tool. Sorry, not the route airwave tool, the move tool. And we can move things about and we can position them where we want. Lastly, there's a fun little thing called the auto router, which you don't have to read too much into this. Just when this window pops up, you hit continue and hit start, and it'll generate kind of random paths that you might want. So the first one for now looks good. And maybe if we didn't like that, we could come in here with the move tool and maybe reposition things. So yeah, and then last steps, we'll want to do error checking. So if we come into here, we can check for errors, and it looks like there are no errors in here. If we'd, for example, I'm going to rip up just a demonstration, so I'm going to control click and remove this, and come up and do error checking again. It's going to tell me that we have this wire is not actually attached. And so to fix that, we'll come back in here, click and drag, create our wire, and then you can see the error is gone, and we're all set to go. So this is the basics of a circuit board. And any questions up to this point? Because we're going to next step will be to show how to get such a circuit board assembled. And then I'll talk you through some more complex circuit boards that I've built in the past. Cool. All right, let's continue on. So at this point, we can save what we have. And we'll just save this to the desktop. And we'll also want to go back. If we click up here, we can go back to our schematic at any time. So click the schematic, and we come back here, and we'll save this as well. And we'll check the desktop, and we can see there's our board, and our schematic file. So at this point, we can go to, sorry, I just closed all my windows. Let me open them back up. Cool. If we go over to dirtypcb.com, PCBs, this is the site that I like for ordering circuit boards. You can just upload the board file that you created in the second step, and you can send it off to them, and they'll turn it into a circuit board for you. So if we go to desktop, grab our board file, grab the sketch, not the board file, BRD. You can choose different materials, and I'll leave that up to you to read through. EagleCAD, the free version, only supports 2 layers. We'll leave it at 2 layers. If you want, ProtoPack is just about 10. Max size is 5 centimeters by 5 centimeters. And if we come back over here, we'll see that, let's see, this is roughly, so circuit boards are in mil, which are quarter or thousandth of an inch, I believe. Let me double check that. Yeah, so 1 mil is a thousandth of an inch. And if we look up in the corner, we'll get the full size. So we see down here is the origin 0, 0, roughly right there. And then up here it is roughly 650 mil by 650 mil. So if we do 650 mil to centimeters, we'll see that this board is roughly, it's very small. It's almost 2 centimeters squared. But that is more than enough to fit in here, so that's fine. You can pick your colors. I'm a sucker for blue, so I usually go blue. If you want to add, so silk screening is the process of all the gray that you see here, so 2 Arduino D1, blue, 220, R1, get printed on the circuit board. And so you can choose not to print silk screening, or what I like to do is I just like to move the text underneath the component so that when I actually do solder on the component, you don't see the text anymore. But you kind of have instructions when you're soldering your circuit board together to do so. Cool. So when we come back here, thickness, it's up to you to choose. Most of these settings I kind of just leave standard. Standard. And if we add to our cart, actually see what's under advanced options. I don't even know what those things mean. So we'll collapse that down. Interesting. 0 length file. Oh, because they somehow lost the file. Let's try that again. Okay. So the cool thing about dirty PCBs, and there are other websites that you can use as well, so I'll leave that up to you to research websites that you prefer, but when you upload your file, you actually get a preview of roughly what it'll look like. So you can see that the top of the circuit board will look like this, the bottom will look like this, and those will be where it drills the holes through so you can pass the wires through. Lawtip says, just did this while watching you. Uh-oh. That's a funny 404 page, but I don't think that's what you meant to share. So copper is the actual, so it'll use copper to make the connections so you can see where the traces are. That is what it looks like on the top and the bottom, and then the silk screen is the text a little bit displayed on top. Bottom, there's nothing on the bottom, and such. And then the blue background. I'm not actually sure what that means. But yeah, so this is what a circuit board would end up looking like, and then you could send this off, and if you went over to SparkFun, if you ordered a pack of female headers, if you ordered a pack of LEDs, and you ordered a pack of resistors, you could then make your little circuit boards. Let's see what we got. Ooh, very pretty. Oh, cool. So this is, all right. So we have the RGB. I like your Y organization. It's very nice. 3 resistors to control a white or a multicolored RGB LED. I like this. Well done. More patience for wire placing than I have. I will give you that. Yeah, so that's about how one makes a PCB. And so basically, let's see if we can find a PCB that might kind of show So might be like a. So this is the kind of like PCBs that you could design, and they're even on sale, or you could build something and sell it. And so it's got. So these are what I talked about with surface mount components. This is the underside of the thing. So this looks like this is a microphone, and it gives you pins that you can solder here that you can then connect to your computer. So this microphone right here, you can see has two pins coming out the back, and so that give it the through-hole bit. So you can see they connect here. And you can see traces are these lines here, which kind of move the electricity about the board. And then we have some traces along the front as well. And then some breakout pins, or we can solder header pins on here to connect it to breadboards and other projects and things like that. So yeah. Any questions up to this point? Cool. All right, so we're going to wrap this up with just going to walk you guys through, guys and girls, through the first circuit board that I ever built. I'm going to switch on Be Right Back mode so I can go and we'll just show it. So this is the first circuit board that I ever designed for manufacture. It is actually the third iteration. Okay. So this is the first one I ever designed. And you've actually already seen most of these. Well, you've seen all of these components today. Obviously, we have our wires, the green pits. We have our resistors. We have ground, which we talked about. We have 5 volts, which we talked about. And then, which I obviously struggled with earlier, push buttons, which I still struggle with. So this is the schematic I built. So all of these header pins were connected or sent off to the Arduino. And then another set of header pins to connect 5 volts and ground to this circuit board. So this might actually be a little bit of a gotcha, and it's kind of confusing to get your head around, but this 5 volts here is also connected to this 5 volts. You diagram it this way so it's easier to understand. You'll actually see these be connected when we switch over to the board view. So we bring up the board. So remember, these are all the pins that go to the various buttons. And then we have all the resistors. And then this is the 5 volts and ground. So you can see 5 volts is connected to each of the buttons. This line, that trace that comes through, connects to each button. And then we can also see ground. Actually, there we go. Not helpful. Anyway. And we also have ground in there. And then we have each of the pins that go off to the Arduino. And so this is my first board. And I think I had an issue in that first one, so I ended up having to order a second board. So in this case, I added these circles here mean that these are connected. So 2 sets of header pins per button. And this was so that you could have either female or male connectors. I should actually bring up what these, if I can type Instagram, bring up what these look like. So this will take a sec to get all the way back in my building history. Chat, if you have any questions at any time, feel free to throw them out there. All right, are we almost back to... Yeah, so here, actually that's a further along version. Let's see. That first version, I don't even know if it actually got manufactured. Anyway, maybe we'll just jump into the final one that ended up actually working. All right, so this is version 1.2. You can see so I sent it was like 3 iterations where the first one was really bad. It actually had some electrical circuitry issues and was kind of a bust. Had to wait like a few weeks for them to show up. Second round also had some issues where I crossed wires, and so 2 of the buttons triggered each other, which was a mistake. And so this is, I think, the 3rd or 4th iteration that everything actually works. I got better at kind of, with time, you figure out how to manage your traces so they look nice and are well organized, and you figure out where to lead your wires and things. And I ended up, let's see, where? Yes. The finished working version that I ended up launching on Kickstarter, 12 buttons with 12 resistors with 12 pins to connect it to 12 different inputs on the Arduino, and you can see ground and 5 volts in the back, and then I added a little LED indicator to let you know that the board was actually on. So that was my first circuit, and I've built 1 or 2 since then, so I don't have too much experience in circuit design. Hopefully going to start manufacturing some more sometime soon, so check back to the stream to see that. That'll actually be my next project, probably in a month or so. So now's the time. If you like what you see and you want to see me build some more complicated circuit boards live, would appreciate the follow here on Twitch. So we are about at the end for day 2. Before we close out, does anyone have any questions? It can be about what we talked about just now or about anything related to CAD code or circuits. Tomorrow will be an open day, so I'll stick around Slack and I'll try and answer your questions if you want to embark on any projects or do. The homework today will be a little bit more complicated, so tomorrow will be your chance to explore that and really get into code and circuits and how they play together. Cool. So with that, we'll switch back over to our slides. And so the homework for you for tonight, yes, our little closing bits. If you check down below in the About section, there's a feedback form. Would love your input on how I'm doing, how I could be doing better, what you like, what you don't like, all that good stuff. Would appreciate your feedback. This week is about me sharing and teaching, but also getting better at doing this so I can do this more often and for more people in the future. Hop on Slack if you haven't already, so you can get help with anything should you want to work on the homework for tomorrow or tonight as well. So, the homework for tonight. Build a project on a breadboard and then convert it to a PCB. Make this as complex or as simple as you want. Maybe do a few different projects, so start simple. Maybe start like wire up 1 LED and then run through the whole process and then figure out how you can do 2 LEDs and then 3 and then 4 and then maybe throw in a button and I don't know, other components and things, and get familiar with Fusion 360, or sorry, with EagleCAD and with Arduino and with Tinkercad and how they all play together. All right. So I think that's about it for now. Looks like there are no more questions, so I will see y'all either virtually, or I guess asynchronously in Slack throughout today and tomorrow, or I will see you bright and early Thursday for CAD. All CAD, all day. Hellcat, you are welcome. Thank you for keeping company. Cool. All right. Peace out. Hopefully I will actually have a working webcam on Thursday. TBD. Law Tib, thanks to you too. Thanks for stopping by. All right. Ciao.